Hello, welcome to the video notes for lesson 7-1, exploring quadratic graphs. This is the first lesson in unit 7, and it begins on page 1, of course, in your notes packet. And let's go ahead and take a look at the targets. Before we get started, you may, if you're a highlighter person, you might want to pause the video and grab a highlighter. We're going to be underlining or highlighting things in here that are really important for you to take note of. Alright, so let's get started. The learning targets. I can graph quadratic functions of the form y equals ax squared. So that's going to be the first thing I'm going to highlight, or you can underline. And then the other target, I can graph quadratic functions of the form y equals ax squared plus c. So basically the same thing, except for the second one is adding a constant to the function. Alright, so definition. Now you'll see on the screen that some of these things are highlighted. On your copy, I believe they are just bold but not highlighted, so you might want to highlight them. So definition, standard form of a quadratic function. Standard form. Okay, what they basically look like. A quadratic function is a function that can be written in the form y equals ax squared plus bx plus c, where a is not equal to 0. It's okay if b is equal to 0, it's okay if c is equal to 0, but a cannot be equal to 0. It can be any other number. It can be a decimal, it can be a fraction, it can be positive, it can be negative, but it cannot be 0. If it's 0, then we're no longer talking about a quadratic function, because we need this x squared to be part of this. That's what causes, well, when we're looking at the graph, the shape that we see. This form is called the standard form of a quadratic function. Highlight that. Here are some examples. So y equals 5x squared, y equals x squared plus 7, y equals x squared minus x minus 3. Alright, and they go on and on and on. Okay, down below we have the simplest quadratic function, f of x equals x squared, or y equals x squared, is the quadratic parent function. So highlight that or underline it, and you might as well highlight or underline this as well. The graph of a quadratic function is U-shaped curve called a parabola. I often joke around, call it a parabola. Some math teachers hate that, so be careful what teachers you say that. Parabola is the correct way. Now, I'm going to point out some things you're going to see on the next page, but I want to do it now. So there are two things that we can identify looking at this particular parent function. One of them is this point right here, and it has a fabulous name. It is the vertex, and in this case it is the minimum point, and it's the point 0, 0 for the parent function. And I also want to point out, let me change my line here. I want to point out the line that's going through the vertex. This is the axis of symmetry. And the axis of symmetry for the parent function is the line x equals 0. Alright, and I'll explain a little bit more about what that's all about on the next page, page 2. So you can fold a parabola so that the two sides match exactly. This property is called symmetry, and I'm sure many of you have heard about symmetry before. So that the fold, or the line that divides the parabola into two matching halves, is called the axis of symmetry. So we just saw that for the parent function. Now we have two examples here. The highest or lowest point of the parabola is the vertex, which is on the axis of symmetry. I often think of the vertex as the point that the axis of symmetry needs to go through. So once you find that point, you basically have your equation for the axis of symmetry. It's whatever the x value is. Alright, and I'll show this to you really quick. So again, let's point out the lowest point here, the turning point basically, is our vertex. And in this example, the vertex is the point 1, -9. So notice the x value is 1. So when I'm looking at the axis of symmetry, which goes right through there, axis of symmetry, that is the line x equals 1. Over here in this example, the vertex happens to be the highest point, turning point here. The vertex for this parabola is the point -1, +9. And I just did a lousy job drawing that through the vertex, so let's try again. There we go, much better. And the axis of symmetry is the line x equals -1 for this one. Alright? So, those are two very important parts of the quadratic function that you need to be aware of. We're going to be exploring lots of different things with this. Down below, there's a couple of things we're going to also talk about, and that is the concavity, which we've talked about in class. So the first example, if a is greater than 0 in y equals ax squared plus bx plus c, the parabola opens upward or concave up. So if a is greater than 0, so I want to point something out. This right here is basically saying if it is positive. If a is positive, then the parabola opens upward or concave up. The vertex is a minimum point or the lowest point. So you don't need to see the graph to know this. Once you have become familiar with these quadratic functions, when you see a positive number here, you'll know that the parabola opens upwards and that the vertex is a minimum point. Now, down below, I noticed when I was going through and making my notes that this first statement here, if a is greater than 0 and y equals ax squared plus bx plus c, that's the same statement as up here. This is wrong. This is supposed to say if a is less than 0. In other words, if it's negative, then the parabola opens downward or concave down. The vertex is a maximum point or the highest point and of the parabola. Alright, so that's basically it for page 2. Now we're going to do some exploring, and this is where you're going to do some independent work. The video's getting long enough as it is. Over on page 3, you'll see page 3, 4, and 5 have some examples that you're going to be exploring. Page 6 actually has the answer key, so when you're done you can check to see if the graphs that you made are correct, which they are going to be, because I'm going to give you a gift and say, dun dun dun, use a graphing calculator. Yay. I know you're all so happy about this. However, even though you're using a graphing calculator, I still want you to put the table of values in this space here. So you're going to have y. You're going to be, so the first one, you're going to be graphing the equation y equals x squared. Now I would go ahead and graph that first, and then plot it, and then go ahead and in the next one, and then in your graphing calculator, when you use the y equals and the next one down, graph this so that you can see both of them. You can also go to the table feature and see the values here, but I believe your y values will be between -3 and 3. So let's go ahead and write that down. Because once they go beyond -3 and 3, that will no longer fit in this graph. Then you're going to answer the questions below. Describe how the graphs are alike. Describe how they're different. Then you're going to make a prediction about the graph y equals 1/3 x squared, and then you're going to graph it on this graph. Same thing over on page 4. You have some space. Sketch your table here. See what happens when we add a constant to the function. So you're going to be exploring and learning about these. And then, of course, on page 5, y equals x squared and y equals -x squared. Alright? So good luck. Remember, page 6 has the answer key, so that's why I'm not going any further. I don't want you to see that before you do it. No peeking, please. Do your best, and we will be discussing this in math. If you have any trouble with any of this, you can come and see me or see a friend for help. Good luck, and we'll see you in math.